Welcome to lecture for Psych 350. We'll be talking about the research relevant to the biological approach. Start off talking about how scientists study the genetic influence, genetics being the primary thing we'll talk about in terms of the biological influence on personality. Much of the evidence comes from twin studies, right, where you're comparing monozygotic and dizygotic twins. Monozygotic being identical, and dizygotic you may know as fraternal twins. From a multitude of studies, we know that monozygotic twins tend to be more similar to each other than are dizygotic twins similar to each other. Right? So you're not comparing a monozygotic twin to a dizygotic twin. You're comparing two twins to each other, to their twin partner, to their sibling, in on a variety of measures, including several measures of personality. The correlation, or the level of one twin's trait, extroversion, openness, neuroticism, whatever, is more similar to their sibling if they're monozygotic twins than if they were dizygotic twins. We also interestingly know that dizygotic twins are more similar to each other than our non-twin siblings. And this is interesting and relevant here because on average dizygotic twins are no more similar genetically to each other than our non-twin siblings. Right? Whereas monozygotic twins obviously are more similar to each other. They're almost genetically identical, not 100%, but pretty dang close. And the correlations range depending on what you're looking at, but generally around the 0.5 area on average for personality variables. One thing to kind of keep in the back of your mind, think, well, okay, that's pretty good, but you'd probably think something like height, for monozygotic twins, identical twins, the degree to which one twin's height is related to another, you probably think, well, that's probably 100%, right, a correlation of 1. No, actually it's 0.86, which is higher than what we find for personality, but still not a perfect correlation. They're not exactly the same height, despite being nearly identical genetically. But again, the key point from the twin studies is that identical twins are more similar to each other than our dizygotic twins, which is taken to be evidence of genetic influence, because it's assumed that monozygotic twins, these twin sibling pairs, twin siblings in a pair, have similar environments to each other, but their environments are no more similar to each other than are the environments of two dizygotic twins, two dizygotic siblings. Right? So if they have the same amount of environmental input, both pairs, but one pair is more alike, then it's thought, well, that must be due to the difference in degree of genetic relatedness. Okay. Which of course wouldn't account for the second point that dizygotic twins are more similar to each other than our non-twin siblings. And obviously you think, well, non-twin siblings may have similar environments, but dizygotic twins probably have more similar environments to each other, right? Because they're born at the same time. Right? Non-twin siblings are born at separate times, and so their environments will be different. One of them will have an older sibling, and the other will have a younger sibling, and that creates a different environment in some ways. We also know about the genetic influence from adoption studies. And in general, the heritability estimates from these adoption studies are lower than when looking at twin studies. So when twin studies say, oh, the heritability of this personality trait is 60%. You look at adoption studies, and they get heritability estimates that are much lower, usually half of what are claimed in twin studies, which suggests we don't really know how much. Nobody has a good idea of what the heritability estimates should be. And we'll talk in a minute about exactly what heritability estimates are, but just kind of know that there's disagreement about even what the numbers are, depending on how you look at the question. But despite the fact that the heritability estimates are lower, we do still have support for genetic influence on personality from adoption studies, and one of the most important supports is that adopted kids are often similar to their biological parents in terms of personality, even if they've never met or spent an extremely limited amount of time with that biological parent. And sometimes, not all times, depends on what you're measuring and the study you're looking at, sometimes they're more similar to their biological parents than they are to their adoptive parents. Again, that depends very much on what you're looking at. And then we don't have many of these, but there are these kind of rare studies where we have twins reared apart, right, where you have these usually monozygotic twins that are almost genetically identical, raised in separate environments, and yet they're still fairly similar to each other. Not as similar as they would be if they were raised in the same environment, and also not as similar as two dizygotic twins raised in the same environment, but still more similar than you would expect if genes played no role. So genes definitely play some role in the expression of personality. Right? But whenever you're reading these studies, oftentimes they can be difficult to interpret because they use some pretty fancy language. But one of the things they almost always cite is some sort of heritability estimate. Right? And heritability estimates are often misinterpreted, even in our own text. They're interpreted as evidence of the degree to which some trait is due to genetic influence. And that is a misunderstanding of what a heritability estimate is. So to understand that, we have to kind of look at a couple of things. One, genotype and phenotype. Genotype or genotypic variability, those are your genes. Phenotypic variability, phenotype, that's what you see out in the world, right? So if we look at phenotypic variability in some sample, so people differ in how extroverted they are, right? And we get some measure of variability, and that can be, you can look, think about standard deviation, range, that type of variability. There are differences, individual differences in what we see in the world in extroversion, and that's phenotypic variability. Now, why is there the variability? What can account for the variability? Well, it must be some combination of individual differences in genetics, and some combination of individual differences in environment. Right? So what a heritability estimate is, it says, okay, well, it's the amount of genetic variability, so the amount of genetic differences there exist in the sample you're looking at, divided by the amount of individual differences you see in the observable trait. So really, it's kind of like a correlation estimate. It's a correlation between one type of variability and another. It's a relationship, and so because of that, it applies to talking about explaining why people are different, but you can't explain cause and effect with this kind of association data, correlational data, because you didn't manipulate them. You didn't manipulate their genetic variability. You didn't manipulate their environmental variability. And since you didn't manipulate it, you can't make cause-effect interpretations. All you can say is there's an association. When people are this different in terms of their genes, we see this level of difference in the phenotype. When they're very similar in their genes, we see this level of difference in their phenotype. Right? So when two twins are very similar, they have low genetic variability, and if they also have low phenotypic variability, right, then we have high heritability. Okay, but again, these are based on large groups, populations, and so they don't say anything about an individual, how much your extroversion, intelligence, openness, whatever, how much of it is due to genetics. We can't say. There's really no way to study that currently. And then the other thing, another problem, kind of interpreting heritability estimates, even explaining what it should be used to explain, is that it assumes independent additive effects. So we go back up to that formula at the top. Phenotypic variability is genetic plus environment, and that's not really the case. It's genetic plus genetic variability plus environmental variability plus some interaction factor of genetics interacting with environment. So it's not just level of genetic difference and level of environmental difference, because some genetic differences create environmental differences, and certain environmental differences may actually impact genetic differences. Right? People's gene expression changes over time. So it's not simple genes plus environment equals phenotypic variability. But the heritability estimates can't mathematically take that into account. And usually they plug in some constant to estimate it, but cannot accurately do so. So the overall point is, don't get carried away when you look at heritability estimate. Oh, something's highly heritable. It must be this. So this thing is due to genes. Not necessarily. Just kind of heritability quantifies how much of the total phenotypic variation in a population is attributable to variation among individual genotypes compared to the variation in the environment. Right. So that means that if we increase the environmental variability in a sample studied, right? So if we look at a more diverse population, we would get a lower heritability estimate, regardless of the role that genes played in influencing that trait. Right? The more different people we look at, by nature of the math, the heritability estimate is going to be lower. And if we look at more similar people, so if we look at just one family all raised in the same town, and that's our sample, we'll get higher heritability estimates because we've decreased the environmental variability. Right? So the fact that the heritability estimate changes depending on your sample should tell you a little bit about what it means. And what it means is, well, we don't know, not much. It's an index to some degree of genetic influence, but it's not a measure of how much genetic influence there is. Right? Okay, so not surprisingly, there are some challenges to the conclusions drawn from genetic studies. And one of the main ones is challenging the equal environment assumption. The equal environments assumption is that the similarity in environments between one identical twin and another, so the degree to which they have a shared environmental influences, is the same as the shared environmental influences for dizygotic twins. So monozygotic twins, their environments are no more similar to each other than are the two environments for two dizygotic twins. And that may not be a tenable assumption, because monozygotic twins may be treated more similarly than our dizygotic twins. And there's some evidence of that. They're more frequently dress similarly, have more similar sounding names, will do more things together. So they may have more similar environments. And if they do have more similar environments, if there's not an equal degree of environmental similarity across these two types of twins, then higher correlations for monozygotic twins than in dizygotic twins may not be just due to greater genetic similarity. It may be due to greater environmental similarity. Right? So that's a significant challenge to interpreting those data. And I don't think anybody would argue, well, the difference in correlations for monozygotic and dizygotic twins, those can be entirely explained by level of similarity of environment. I don't think anybody would argue that, but they would argue about the magnitude of the influence of genetics that people conclude from these differences. Because okay, the correlation is this different, but some of that difference is due to a difference in similarity of environment. How much? We don't know. Just kind of caution you to, when you start seeing people put numbers on, okay, this much of your trait is due to genes. Anybody that says that is usually probably misinterpreting the data. Another problem is determining the degree of genetic relatedness, and a couple things about this. One, as your book talks about, in a lot of the studies that we rely on, when people are classified as either dizygotic or monozygotic, it's based on self-report or parent report. But sometimes they're wrong. Sometimes parents may think that they have identical twins because they look very much alike, but then if they never had genetic testing done, if they didn't have, their prenatal care didn't include scans that determined whether or not they were monozygotic twins, then they may not really be identical twins. The other thing is, when they come up with these heritability estimates, they look at degree of genetic relatedness, and they assume for monozygotic twins they're 100% related, and for dizygotic twins they're 50% related. And again, the 100%, not exactly, but it's close enough that I won't argue with that one. But the 50%, that is on average, right? Monozygotic twins, all dizygotic twins do not share exactly 50% of their genetics. Right? It's a range. On average, if you get a whole bunch of dizygotic twins, thousands and thousands of them, and you look at the degree of genetic relatedness. On average, it'll be 50%, but it varies significantly, just as do all siblings. And that's why some dizygotic twins will look more alike than others. Some will be the same sex, and some will be the opposite sex. We'll clearly see we have some pretty significant genetic differences in terms of XX or XY, right? So some of the again, going back to the heritability estimate, some of the math is based on assumptions that aren't really supported by what we know about genetics. And then the other thing, just kind of keep in mind when reading about adoption studies, regardless of what they're used to, either to support a genetic influence or to contradict a genetic influence, is that adoption leads to a different environment than other family situations, and it's unique in several ways. The families that adopt kids, on average, and this is a generalization, but on average, are wealthier, more stable financially and emotionally than the typical family, right? Because there's frequently a rigorous screening process in order to adopt, especially if you're adopting a child that's not biologically related to you in any way. It's not your grandchild or your niece or nephew or anything like that. So those families are different, and so you have to kind of keep that in the back of your mind when trying to make sense of data that comes out of those adoption studies. Okay, so evidence for genetic influence, it's strong, but not unequivocal, and is frequently overinterpreted. Moving on now to extroversion-introversion, which will immediately come right back to heritability. And again, like I say, people tend to overinterpret things. So the text makes the argument here that whether or not you can make someone more or less extroverted or introverted depends on if it's genetically influenced or not. Now, this is a gross oversimplification of the interplay between genetics and environment. Height is most certainly influenced by genetics. But if we can change how tall you're going to be, how tall your child is, well, that depends if it's genetic or not. Okay, so it's genetic, so you can't change how tall your kid's going to be. Not true, right? We know that big scale stuff, people in certain countries are getting taller from generation to generation, right? And it's not because their genes are mutating for taller genes. We can identify it's because their diets are improving, right? If you want your kid to be short, don't give them any milk. Right? If you want them to be tall, give them lots of milk and protein. Right? Diet interacts with genes to give rise to height. Same thing for any measure of personality. It does change in response to environmental influences. Now, granted, the degree to which genetics influence a trait will influence the degree to which that trait is amenable to change. But again, this is all about degrees. It's not yes, it can change, no, it can't. Yes, it's genetics, no, it's not. It's degree of genetic influence and degree that it's amenable to change. Right? Because even if a trait were 100% influenced by genes, it could still change in response to environmental inputs. Why do I say that? Because which genes are active, right? Which genes are producing proteins, changes in response to environmental inputs. Genes aren't this blueprint you're born with, and these are your genes. They're biological. They're organic, so they change in response to environmental inputs to some degree. But for extroversion-introversion, monozygotic twins are more similar than dizygotic twins. Right? In general, there are higher heritability estimates for extroversion-introversion than for other personality traits. But again, take that with a grain of salt, because heritability estimates don't mean what most people think they mean. In terms of evidence related to the relationship between extroversion-introversion and preferred arousal level, there is support for the supposition that introverts prefer less arousal, less stimulation in the environment, and extroverts prefer more stimulation. Which, just for me, I've seen with this, and it's interesting because I consider myself generally an introvert, and in some ways I do prefer very low levels of arousal. I watch TV frequently with the volume turned down and the captions turned on. Which annoys some people. But then they talked about, where do you sit in the library to study? And I always chose the big table out in the middle because I couldn't concentrate. I'd fall asleep if I went into one of those little rooms or one of those little cubicle things. So for me, this kind of reminds me, okay, yes, I do see where I fall on this spectrum, but when you're looking at any individual behavior, say, okay, what is this person going to do, and what do I know about the personality? Well, just because you know something about the personality doesn't mean you can predict with great accuracy what they're going to do in a particular situation, because every behavior is determined by more than one trait. And in addition to being influenced by traits, it's also influenced by other environmental inputs and recent experiences, right? Learning. But in general, there is support on average for this relationship between preferred arousal level and extroversion-introversion. Last thing about extroversion-introversion, happiness. Extroverts in general report greater happiness and well-being, which is thought to be generally due to greater social contact and also greater seeking out of happy-producing experiences. Right, they're high in sensation-seeking, so they'll go do stuff to feel good. Whereas an introvert who isn't feeling that great, less likely to go out and do something about it. But interesting, it's also in terms of mood differences. One thing that I don't think they mention in your text, but it's in one of the studies they cite. Extroverts also tend to experience greater mood variability, right? So greater happiness, but they also have more changes in their mood. Introverts tend to have more stability. Again, probably related to that sensation seeking. If introverts don't go out seeking more inputs, then the mood is probably going to be more stable. So if you're introverted and fairly happy, you're probably going to stay that way. If you're introverted and fairly sad, you're probably also going to stay that way. Whereas if you're extroverted, however you're feeling at a given time, it very well might change depending on when you go out to seek out some new sensation, depending on the outcome, if it makes you feel good or makes you feel bad. Okay. Last thing to talk about would be mate selection and evolutionary personality theory. So evolutionary personality theorists talk about what people look for in a romantic partner, and this is assuming a heterosexual relationship, depends on a degree of parental investment. So what you have your vested interest in the parenting. And the book seems to contradict itself at one point. I want to kind of clarify, because at one point they say, as members of a species, we are concerned about reproducing and passing our genes along to the next generation. Right? So it makes it sound like we're concerned about passing our genes along. Oh, geez, I better pass my genes along. Ooh, got to do that, otherwise the species won't survive. But then, 2 sentences later, it says, this analysis does not suppose that we actively consider reproduction success when we select among potential dating partners, but that certain mate selection preferences have been passed down to us through evolutionary process. Okay, so the second part of that is more accurate, more akin to what the evolutionary personality theorists believe. They don't believe that we go out looking to pass on our genes. Right? Men don't go out and say, "Oh, she looks young and fertile. I'll have a good chance of having many children with her that will go on to have many children, and my seed will be spread far and wide." That they don't believe that's how people think, that it's a conscious motivation, but rather that people who historically thousands and thousands of years were successful in reproducing passed on their genes. People who were unsuccessful in reproducing, who didn't have lots of kids, didn't pass on their genes. So the genes that are left in our current gene pool may be related to the personality characteristics of the people who were successful, right? Assuming that their success in mating was related to personality characteristics and what they looked for in a mate. Okay, so that's the big idea of it. What do men want? What do women want? In general, the evolutionary theorists believe that men want fertile women, right? So what men value, what they look for in a partner, and what women seem to promote when trying to connect with a mate would be physical attractiveness, not because of any kind of abstract value on an aesthetic, but because physical attractiveness thought to be an indication of health and fertility, right? Different things, skin, hair, In terms of weight, one of the interesting things that I don't think your book mentions for some reason is there seems to be across cultures a certain hip-to-waist ratio that men find attractive. So not skinny women, not big women, but depending on the ratio between the hips and the waist, there seems to be some ratio, which again, men aren't out there with calculators figuring this out, but that lights up men's brains and makes them think, "Ooh, that's attractive." And that hip-to-waist ratio seems to be associated with reproductive success. So, oh, she has good birthing hips. There's, according to evolutionary personality theorists, there's something to that. That people who sought out women whose bodies were shaped in a way that seemed to be associated with reproductive success, that is valued, and so now that becomes attractive to us who are left with the genes passed down to us. Right? And there's cross-cultural support for some of this in terms of men from a variety of cultures prefer young, healthy-looking women, and not too young. So it's not like they like kids; they like women who are of childbearing age. Right? And so. Ironically, in some ways, in our own culture, there's a mismatch between what's promoted and valued, promoted to women as an ideal, the thin ideal, and what evidence from a variety of studies seems to support that men really want. So what's promoted frequently is this kind of waifish, super thin woman, but the research suggests that men aren't necessarily attracted to that. And eating disorder research supports also that women think that what men find attractive is much thinner than what men say they find attractive. Just a side note there. So what about women? What do women want? Again, they're thinking about parental investment. So men, the only thing that matters to them is spreading their seed far and wide. Men who had lots of sex with lots of fertile women passed on their genes. Right? So men are left with genes now that make women who look fertile attractive. Interestingly, the same logic not applied to women. So women necessarily looking for a fertile man, which you would think makes sense. Instead, women want a man who can provide resources. The idea being that among the cave people, men didn't have to stick around and protect children for the children to be successful and live, but that the mothers did. So the mothers are more tied to not necessarily having lots of kids, but the mothers are tied to making the child survive. And one way to make children survive is to make sure they have lots of resources, right? So a nice cave, plenty of woolly mammoth to eat, whatever they ate. So currently it's found that women tend to rate a man's ability to provide, to earn a living, his motivation to succeed, ambition, his power and status as attractive, but only if he's willing to share and provide for the family. So really dominant men, that alpha male who has lots of stuff, attractive, but only if it's perceived that he would be generous and share it with the woman and her offspring. Otherwise, it's of no use to her in an evolutionary sense. Okay, and again, cross-cultural support for this too, where women from a variety of cultures tend to rate as attractive men who are able to provide, who have stable employment, who are reliable and dependable. But, as we've talked about before, there are certain limitations to the evolutionary personality theory, the first of which we've talked about at length, falsifiability, right? You can't really falsify this, and if things were different, we could still probably explain it using this theory, which makes it not a falsifiable theory in some ways. And the other thing is that it's not consistently supported. So certain things we notice, we say, okay, yeah, this makes sense given evolutionary theory, but then other things, okay, if the theory is true, then we should see this. And it doesn't always find support. And that does seem to be a tendency, if you read the literature here, is that things that are supported are things that people have already kind of observed. Okay, the people are this way, that makes sense from an evolutionary point of view, so it's going from data back up to the theory, which is backwards as far as science is concerned. You should have a theory and draw down hypotheses from that theory. Okay, if the theory is true, then I should see this. and then you look to support or disconfirm the hypothesis, and that then tells you something about the validity of the theory. And that doesn't seem to happen very often. And when it does, the theory is not often supported. So it's of limited utility other than makes good fodder for morning talk shows. Okay, so summing up all this stuff, biology definitely plays a significant role in our behavior and in the consistency of our behavior, which is our personality, right? But I would argue that what tends to happen is people get caught up in the question of the degree of influence. How much is biology, how much is environment? But I would argue that that's not that important because, again, I don't think that the degree of influence tells us much about the degree to which a trait or behavior can be changed. And that's an assumption some people hold. So, well, if it's genetic, then there's nothing you can do about it, right? And that just doesn't seem to be true. Even if it's genetic, environment can change your behavior. All behavior is modifiable. The degree to which you can modify behavior is probably limited some ways by genetics, but I'd say never entirely. It may take more of an environmental manipulation to change some people's behavior than others. But to say that certain people just can't be a certain way, I think is a misunderstanding of how flexible we are and how amenable to change people are. So some people say, oh, people never change. Yeah, people change all the time. Circumstances are hard to change. Environment is hard to change. There's an inertia to our world, which tends to make people look more stable than maybe they would be otherwise. But if you can get significant environmental change, you can get significant behavioral change and change in personality. So I would argue, again, the focus should be on how biological influences, genetics, interact with environmental influences and perhaps other variables to lead to personality and to contribute to the ongoing development of our personalities. Okay, so I will get off my soapbox now. That's it for now. Take care.